So I've only got about an hour. So let's do something easy first. Let's start by, okay, let's organize a to-do list here. I mean, I just have a bunch of to-do items, but let's actually make a list so I can check stuff off. First thing I'm gonna do right now is implement scrolling. What else? How easily could I do back-to-back gates? I think I can do that in an hour. But anything beyond these two things is going to be tough. And then next time I need to implement junctions for sure. Really, really need that. I might be able to squeeze in copy and paste. Well, I mean, it's easy to copy and paste. Like I'll just make an array and deep copy to that array, and then deep copy back to the grid. And it's not an issue, but the hard part will be coding it up in the UI so that it's easy to use. That thing about toggling connections and nets to gates. All right, let's just work on these two. So scrolling should be fairly easy. So cursor position always in, like always relative to current viewport. Vx vy equals 0, 0. This is the viewport into the map. Let me think about this. So in here, if we're moving the cursor, so I don't really see a good way to do this other than if Cx less than 0, then Vx equals else if Cx, and also we'll clamp Cx to 0, greater than 15. Here we want grid width minus 16. We'll just assume the screen is always 16. Then we'll do Cx equals 15. And we need a similar one for Cy. This is going to be GH. Okay, and then oh. It's because I'm meeting someone at a vague time later, so I gotta watch my phone. Anyway, where was I? So this really is Vy plus Cy and Vx plus Cx. Now the cursor, this is fine. Ah, man. Nah. This, well, okay, no. Man, this is kind of ugly. It's not relative to the current viewport. This is absolute indices into the grid. Because it'll make things way too difficult. Not difficult, but just messy. The thing is that we need to know where to draw the cursor and where our viewport is. So, in theory, these could be equal, but Cx and Cy can be a little bit further ahead of Vx and Vy. This is like not a really nice way to do it. So the viewport corner moves if the cursor is too far away, or like, yeah, anyway. If the cursor strays outside of between viewport and viewport plus 15, then we try to move the viewport. It might clamp out, but whether or not it clamps out, we always set the cursor to the, yeah. I think this works. Now, over here, this actually is fine like that. The only thing we need to worry about now is where to draw the cursor. So this is actually simply going to be Cx minus Vx, like that. Cy minus Vy. And likewise for this. Oh, actually, can we do like camera? How does that work? I've never used camera in Pico 8 before. Set a screen offset of -x minus y for all drawing operations. Yeah, I mean, let's try it. I think that'll fix my problem pretty nicely. Whoops. Whoops. And then here in the map call, I have some explicit arguments. I think these need to change now that I've moved the camera. Draw a section of map starting from blah blah at screen position blah blah. Map is often used in conjunction with camera. All right, let's just try it. Now I'm pretty sure that map only uses as much. Let's just try this first. Very carefully draw this, and then we'll see if we can move it. Okay. Okay. Okay, the draw grid function needs a little more smarts, I think. Draw the 16 by 16 subgrid starting at dx dy. If full is truthy, write all of the grid. This actually looks like it should be right, though. Let's put in some debug statements. Yeah, I need to fix that text. Oh my god, okay. Camera messes up a lot of stuff. Can you get the current camera settings? Yeah. So I need to edit. All right, let me do this and that and go in here. So I need to save the current camera settings. The X and Y offsets are stored as 16-bit signed integers with the least significant byte first. So the X and Y, let's try that. I think I need peak 2. So local old X equals peak 2. Whoops, that's not what I meant. Okay, like that. Local old Y. No idea if this is going to work. And then poke 2. So we do all this, then we put it back the way it was. All right, wow, I can't believe that works. So yeah, why are my OX and OY 0? I don't think that's right. Where is this draw grid? Oh, why is that 0, 0? This should be VX, VY, right? Yeah. Well, that was easy. Yeah, I now need to fix this box up here. Would be nice to be able to like select a box and erase in a box, but you know, whatever. At least this is working and the performance seems to be okay. I don't even know why I'm bothering to erase all this. Let's get a feel for how big this whole map really is. Oh, how come I can't draw down here? Wow, yeah, I mean, you can really... Oh, man. Okay, there's some weirdness going on at the edge of the screen that I need to deal with. Ah, it's the linear coordinates. It is the linear coordinates that are screwing me here. I need sentinels. Okay. So... fix text. Fix text placement. Fix wraparound. All right, let's start by fixing the text because that's pretty easy to do. Vx times 8 plus and Vy times 8 plus. Yeah, actually, I think that should fix it. Yeah, I think that did it. Yeah. Yeah, okay, good. So we did that. Now we need to fix the wraparound, which I'm trying to think of how to do that. So oh, right, there's also that other bug I need to fix, which is fix not being able to draw in the bottom half. So, man, the wraparound is, so, okay, my first idea is I will make the width, right, this up here, I will just make it 129, right? Well, yeah. PW real equals 128. So I need use 129 in most places. Acts as a sentinel, so linear cohorts don't appear to wrap around. This is like the real one. It's the real width. So we'll use the safe width everywhere we can. And the real width, where does that need to get used? I think it only needs to get used here. I think we really just need that. Like, as long as we can't put the cursor, I think this works. Go all the way to the end. Oh my god, man, this is really big actually, which is good. It sucks when it's too small. Can't see what I'm doing. Well, there's no wraparound this time. So, mission accomplished. Oh, now how come the performance got really low there? Look how smooth this is. Look how choppy that is. Why is that? Why is this so choppy? Maybe it's just my imagination. I don't know, it feels choppy to me. Alright, so I think we fixed the wraparound. I'm just going to mark it as done. Now, let's see if we can figure out why we can't draw past a certain point. Whoa, whoa, what is going on? Oh, and everything's fine. Oh, it's because my, okay, something went wrong with the text. Grid height should be 64, right? I think maybe all right, let's print out Vx and Vy. Oh my goodness. Once Vy gets past 16, like everything goes off the rails. When we're at 15, it suddenly spikes up. Like, oh, okay, because the text Something's wrong with the text. Why? Is there a bound on the camera? Is that what's going on here? All right, hold on. So I just noticed in this thing I'm looking up here that actually I think camera returns the old X, old Y. So actually we can do this. I don't think this will fix the problem, but it might. I don't think this is the problem though. Okay, so let's turn on, let's move to the right a little bit, debug mode looks fine, move down a little bit, debug mode looks fine. So the minute we hit 15, what? It's nothing to do with draw grid. What the heck is going on with the text just like warping off screen? We go too low, everything dies, and it stays bad until we're back. Let's keep going. Then it stays bad. Like what? I think it has to do with this text here, but I don't understand why. Let's just see what happens if I do this. Okay, so the text has something to do with it. I don't understand why though. I think the text is scrolling the screen, and scrolling the screen is really, really, really slow. So something is not right with this. I think print is just... Alright, let's try this. Let's try... how do you do this? I know you can put \0. Oh, it does an O, not a 0. That's still wrong. Okay, so it looks like this printing is just effed up, so let's not do this. For some reason, even if the y coordinate is of the bottom of the screen due to the camera, the print function always scrolls the screen if the cursor is past 128. So reset camera when printing, I guess. All right. We still can't draw down here though, which is strange. Except we can? Just doesn't render? So at least we fixed the text. Maybe mset just doesn't work if you go past 32. So if I do this, yeah, it looks like mset just doesn't work if you go past 32. What the heck? There's just something messed up if you try to use all 64 rows of the map. I wonder if this has to do with the default clipping coordinates. Let's try printing Okay, x begin is 0, that makes sense. Oh, actually I think it's just peak. I think it's just 1 byte. Y begin 0, that makes sense. X end 128, that makes sense. Y end 128. I don't think that's what the problem is. I'm running low on time here. I'm definitely not going to be able to do back-to-back gates. I'm barely going to be able to fix this weird issue. Okay. Controls width of the map in cells. Default is values 128 and can be set to 0 to make that 126 or 256 cells wide. The height of the map is influenced by how many bytes in memory it occupies. Note these locations do not influence the built-in map editor. It always works with the data at 0x2000. They will only affect the functions. Okay, there's some release notes that they link. This is a pretty old release, I think. Where's the date on this? 2021, not that old. Okay, apparently alright, maybe I did better just put this on the screen here. Whoops. No, that wasn't it. Alright, let me try and, I'm just trying to parse what I'm reading here. 64K of base RAM is not enabled by default. In 0.2.4 it is safe to peak Pokemon copy memory 0x8000 and above without setting off the hardware extension bit at whatever. And since it's possible to poke or mem copy out of range. Additionally, 0.24 introduces the first feature that explicitly uses the upper 32K section big maps. The video memory sections can now be mapped to each other, allowing the screen to be used as if it were the sprite sheet, and or to draw to the sprite sheet as if it were the screen. The mapped address for the sprite sheet is stored at blah, and the mapped address for the screen is stored at blah. There are only two legal values that should be poked to each address: 0, which means mapped to 0, and 60, which means mapped to 0x6000. Here's an example of recoloring and zooming a section of the screen, pasted at the end of the draw point. This was possible in the earlier version, but required a lot of mem copying. Set the screen memory as the sprite sheet and stretch screen to screen. I don't think I care about this. Similar to graphics memory mapping, the map can now be placed at address 0x8000 and above in increments of 0x100. This gives 4 times as much runtime space as the default map, and an additional poke is provided to allow custom map sizes. Legal values are 0x20, the default, and 0x80 and above. There are 2 pokes you need. So this sets it to 0x80. The height of the map is determined by how much data is available in the memory section. So in this case, there's 32K available divided by 256, which gives the map a height of 128 cells. Note that the map editor still always writes and loads at 0x2000. So the cartridge page. The map address is observed by all map functions. Now, okay, so many ads. Now, the map here, the map is 128 tiles wide by 64 tiles high. Each byte represents, the map is read from left to right. Okay. Why don't we, well, no, wait a sec. Man, I don't understand what's going on here. If I try to mset, it will corrupt my sprites. Yeah, no, but that's what should happen. checking to see what happens if I go too low. I don't know if that'll work. Whoa. Cool. Well, that's not what I want. So all right, what happens if I do m set 0, 32, and let's just put, I don't know, 13 or something. And if I do m get 0, 32, comes back as 13. Oh, I think I just realized. I think the defaults for map, the map, the cell W and default, aha! To draw the whole map, including the bottom half. Yes. Okay. And by the way, while we're here, let's just double check, according at least to here, what the map function does for performance. N is the number of sprites rendered. Only cells that are not 0 in the map are considered. So, yeah, I think it's fine. Okay, I think that'll fix my problem. I just have like a blank call to map somewhere. I could have searched for it, but yeah. So we want 128 by 64, and that should fix my problem. Yeah. So, and now if I check, yeah, OY is 48. Yeah, I think that fixed my problem. All right. Let's put this back to this, I guess. I don't really know if I need that right now, but anyway. Okay, great. So we fixed that problem. And it's interesting, like if there's more stuff drawn on the screen, like you can see the performance, like, you know, takes more cycles, CPU cycles to, and if I fill it up here with a bunch of stuff, fill it up completely. Actually, we should put some gates in here too, which I'll do in a second. So, alright, let's check our debug window. In fact, let's go ahead and do all of these as well. Okay, so, so we'll put in some gates, not that it really matters what they are. Yeah, actually the performance is pretty good. I think this is fine. Let me just take a look at the, so start of draw grid. So we're using about, like, even when the entire screen is filled, we're using only about 15% of the cycles just to like iterate through that grid array and decide on the tiles and doing the M set. But we're only doing 256 M sets, so yeah, I think it's working all right. All right, so we have implemented scrolling. How much time do I have? I mean, I've only got 15 minutes. There's no way I can do back-to-back gates. Well, is there no way? Let me quickly think about how I would implement that. Well, I mean, actually, maybe it's not as bad as I think. So, like, actually, no, it's down here, isn't it? Update state of all delay elements includes gates. So we check neighbor.state. I mean, maybe, do you think g.port1.state equals g.state? Like, what if we just do that? Do you think that'll work? Nope. At least that still works. Now, how come that doesn't work? Oh, because I don't set it as a neighbor. So, okay, real quick, when we create a new gate, create a new gate for the port. Let's just go ahead and put state equals 0. And like maybe when we place the gate, we just check the neighbors. Well, actually, we only need to check the neighbor to the left. And then when we erase a gate, yeah, this might work actually. This might not be as bad as I thought. So, check if, actually hold on though, because in general, we could have junctions. Well, it's okay if we let the input of one gate it's okay if we let the input of one gate be, you know, the driver of the input of another gate, because it'll just stay 0, which is what you expect to happen anyway. So I guess here we'll just do auto connect to adjacent neighboring gates, and we'll do a to-do junctions. Actually, maybe we can just do it straight in this loop here. What is that global called? Just neighbors, right? Local D is equal to neighbors by do I have the linear coordinate? Yeah, so local NL equals L plus D. Let's just do local N. Am I using an N for anything in this function? Nope, okay. Equals grid of L plus D. If N dot type is gate, then we connect them. And we will have to take care to disconnect them when we erase a gate or a junction. Local Pinum other Pinum N local Pinum S for self, or maybe what did I call it? O G C. I think I just called it G. Equals Pinum lot minus D. And then we will do N dot port Pinum N equals G dot port Pinum G, right? Right? And likewise, oops, not port Pinum N. Seems like it would work. And then over here in erase square, for each port, follow it and disconnect. Huh. Actually, I think that's already done. Maybe this will just work. Oh. Attempt to index field blah, a nil value. Right here. Oh, not quite. What did I call it? Place gate. I needed to do neighbor. I don't like to use semicolons when I'm writing in Lua. Will this work? Oh, I got this again. If n.type is gate, oh, what was the error? 9280. All right. All right. Also, let's check the log. Pinum ng is 1-3. That's exactly right. So what's the issue? N.port.pinum n. Now, the port should always exist, right? Oh, actually, here's an important one. Ah, interesting. I think I have my displacement backwards. So I just placed this one. That's G. This is N. That's the neighbor. Maybe my neighbors are in the wrong order. Oh, they are. I don't know if this is going to fix it. No, I still want to fix it. Now, why is the port num 3 not equal to I? Because 3 is correct. wait, why is this suddenly okay now? But they're not connected. Oh, well, of course they're not connected, because I just deleted this code that does it. Well, that's working now. Oh, I gotta put this back. Like this. Yeah, I think this is working. Ooh. Maybe not. I don't know, why is that happening? Oh, because it's the way we're iterating through the gates. Because we update the state. Yeah, I was hoping I could get around having to, like, compute next state and then apply it. Although, there is something pretty awful we could do, which wouldn't work for the delay element. Well, actually, maybe it would work for the delay elements. So over here, we don't do this right away. We actually do it up here. Yeah. Oh, wait. Now something's not quite right. Oh, it's just the way I was. That's interesting. I think now I have an odd number, or an even number. Oh yeah. Well, I think we can say we did this, kind of. Yeah, oh yeah, I just realized. My original idea for this whole thing, this problem of the back-to-back stuff, was to have implicit hidden nets that would just magically get managed. And that's essentially what I've ended up doing, except the magic hidden net is the port object. That worked out. That really worked out. So what time is it? All right. The next thing to implement is junctions, which I definitely don't have time to get into right now. Let me think about that for a second. We could do them in the same way we do gates, where they basically have port objects for each of the 4 ports with special rules, where instead of in the gates, where we on every frame calculate their internal state and then update the ports. I think the junctions should be a coordinate inside. No. The junctions will still have port coordinates, except their draw, like, how do I put this? We'll figure out how to draw them when we draw everything, like in the draw grid function. We will check, and so the idea is that ports don't break nets the way that gates do. Like, if I do something like this, and put a gate right here in the middle, and even if I connect it up to the wires and all that, these are 2 separate nets. You can see that somewhere. Yeah, here. 2 nets. My idea with junctions, and this is for performance more than anything, is that junctions will not break nets. They will implicitly be part of nets. They'll basically just be part of 2 nets. Is that my cue? Okay, I gotta go in 18 minutes. So I have 18 minutes to think about this. All right. So let me think about it. So this is where we create new nets. So there is a list of port objects that it connects to, which I originally thought that junctions and gates would be separate, but now that I'm doing this port object thing, actually I think I'm just going to put the junction ports in here. And in draw grid, how does this work right now? Yeah, we check if it's a gate. So we can do this if whether it's gate or junction. So let's just go ahead and put that in since we'll need it eventually. I'll just use JCT for junction. Maybe JCTN. Oh, JXN. Yeah, there we go. Now I'm just goofing around. Okay, so yeah, that fixes the drawing for junctions. Okay. I'm coordinating. To be honest, sometimes I feel like meeting up with people, sometimes I don't. But even when I don't, I always do, and then I, have a good time anyway. I'm in one of those moods where I feel like just doing this basically, being a loner. Don't get on my back. But yeah, I gotta coordinate meeting up with people. Anyway, where was I? Yeah, I think this takes care of the drawing, kind of. So, yeah, we need a special case for junctions here where, depending on the type of junction, we will check the ports. Well, yeah, let's just go ahead and do this. So else if O dot type equals junction, then, so we're doing this now. If O dot J type equals flyover, then this stuff, else that stuff. So for the flyovers, we have 4 states. And likewise for the abutting. You know, here I'm trading flyover and abutting as special cases of junction, but honestly, flyover and abutting are special cases of net more than anything. Anyway, I've already started implementing it this way. I also think it's fine to implement it this way, so let's just keep going. If it's flyover, we need to get which tile it is, right? So local T off will start out at 0. If O dot port okay, so for flyover 0, 1, yeah, okay, so ports 1 and 3. If port 1 dot neighbor dot state equals 1, or O dot port 3 dot neighbor dot state equals 1, then actually let's start T off at 2, which is the first one. T off plus equals 1, and we'll do the same thing, but for ports 2 and 4. And then here we'll do, actually we just need Tino. I know a guy named Tino. Anyway, so this is flyover. Do that. Otherwise, and this is like ugly code, man, ugly. Now we can make it a little bit better by doing this, I think. What time is it? 8 minutes. And now the Tino is 6. And now instead of ports 1 and 3, it is ports 1 and 4. 2 and 3. So that should take care of drawing the junctions. Let's get rid of, well, no, let's leave it. There's no point getting rid of commented debugging code unless I'm out of space for more code. Now in here, yeah, so I think drawing is done. Now we just need to consider drawing a junction and erasing a junction. When we draw a junction, we need to do to merge nets together. And actually, I think the way I did the gates how they'll check their neighboring, they'll check their neighbor. Let me just check how that works. Yeah, I just checked neighbor.state, yeah. So that actually, yeah, if I do ports on the junctions, yeah, this should be okay. Although when we create a gate, all right, okay, so when we place a gate, so actually here I think we can just straight up do if it's a gate or a junction. And when we erase a square, if it's a gate, we need to, oh my goodness. Yeah, there's no way. Ugh, I gotta go in like 2 minutes. Let's just make sure that it didn't break or anything. Yeah, we just added support for things we're not using, so it shouldn't break anything, I hope. Oops. Yeah, I think it's fine. How much time do I have? So, yeah, for the junctions, what's left? We need place junction, special case in DFS. Erase square support. We really need an undo stack. Oh man. I can't believe just how much there is to do before this even gets to like a minimum like usability. Unbelievable. All right, I gotta go. I really gotta go. Too bad.